Hi everyone, my name is Yang Zheng from the City University of Hong Kong. Here I feel really honored to present our latest work entitled A Multi-Modal Transformer-based Code Summarization Approach for Smart Contracts. So first we introduce the background of our work. Automatic code summarization, which generates a brief natural language description for source code, can greatly facilitate programmers in code comprehension and maintenance. In recent years, smart contract as programs automatically running on the blockchain has been applied in various business areas to enable more efficient and transport transactions. However, despite its increasingly wide application and promotion, automatic code summarization for smart contracts has not gained much attention yet, thereby introducing some vital issues. The first one is loss of smart contract comments are unavailable, leading it difficult to comprehend and learn code between developers. The second one is a misuse of uncommented code via code clone, may introduce vulnerabilities. To this end, it is necessary to automatically generate high-quality code comments for smart contracts. But automatic code summarization still has some challenges. The first one is how to extract the semantic information of source code. And the second one is how to capture the long-range dependencies between code tokens. For the first challenge, we adopt two heterogeneous modalities of AST, which is a graph and SBT sequences, to extract the source code semantics from the local and global aspect, respectively. And for the second challenge, we employ the multi-head attention structure of the transformer to enhance the ability to capture the long-range dependencies between code tokens. So thereby, we propose a multi-modal transformer-based code summarization approach for smart contracts. So here are some preliminaries. The SBT method converts ASTs into specially formatted sequences and globally keep both the structural and lexical semantics of source code, while the GCN regards ASTs as graphs and propagate information along the edges between nodes, which locally implies both the structural and the lexical information. Besides, we also adopt multi-head attention of a transformer to construct both the encoder and decoder of our model. And this part, we introduce an overall framework of MMTrans. At the beginning, the source code we obtain from the Ether-scan.io is passed and processed into a parallel corpus of smart contract methods and their corresponding comments. Then we transform the smart contract methods to graphs and SBT sequences, respectively, to form the input of MMTrans. The MMTrans consists of two encoders, which is the graph encoder and the SBT encoder, and a joint decoder. The node sequences and edges of graphs are fed into the graph encoder to learn the local semantic information, while the SBT sequences are fed into the SBT encoder to learn the global semantic information. Subsequently, in the training stage, the joint decoder integrates the common sequences, graph encoder outputs, and the SBT encoder outputs to produce a batch of sentences under the teacher forcing method. Finally, the backpropagation is executed based on the predefined loss function to optimize the whole network. While in the testing stage, the joint decoder integrates the previously generated common words and the enable to encode output to predict one word at each time step. At this part, we introduce the data preparation of this work. The initial data set consists of 40932 Ethereum smart contract. After the data preprocessing, we constructed a smart contract code summarization data set of 347410 method common pairs. Then we transform the source code to SBT sequences and graphs, respectively. And finally, we split the data set into train, validation, and test set, and generate 3 vocabularies for SBT sequences, the graph node sequence, and the comments. So this part we discuss our experiments. First, for the quantitative evaluation, the MMTrans performs the best comparing with the 3 baselines of hybrid decom, code plus GN plus GRU, and the window transformer. Then we discuss why MMTrans is powerful. First, we explore the effects of the heterogeneous multi-modalities of AST. Here we adopt vanilla transformer, MMTrans, and MMTrans to make the comparison. The vanilla transformer uses the plain source code as a single input. The MMTrans is an incomplete version of MMTrans, utilizing the graph and plain source code as double input, while the MMTrans has double inputs of graphs and SBT sequences. And all these three models employs a multi-head attention structure. Thereby, we can intuitively observe the effects of multimodality of the AST. From the quantitative analysis, we found the MMTrans performed the best. Then is MMTrans, and the last one is vanilla transformer. While for the instance analysis, we found that only adopting GCN indeed have a better performance than only adopting plain source code as input, but also leaves the MMTrans distracted by the local information. For example, the MMTrans tends to copy high-frequency words in source code. However, adopting both GCN and SBT can help MMTrans weigh between local and global semantic information and get better results. Second, we explore the effects of multi-head attention structure, and we adopt code plus GN plus GRU and MMTrans to make the comparison. For both of them, exploit the graph and plain source code as double inputs, and the former one adopts GRU as its core structure, while the latter one adopts multi-head attention as its core structure. Similarly, we first conduct a quantitative analysis, and we found that with multi-head attention structure, the MMTrans indeed outperforms the latter one. While for the instance analysis part, the code plus GN plus GRU with GRU structure cannot summarize correct comments for the long method, while the MMTrans with multi-head attention structure still can handle them well. To sum up, we for the first time constructed a large dataset for smart contract code summarization, and second, we propose a novel method to handle it entitled MMTrans. The experiment shows that the MMTrans performs better than the state-of-the-art baselines by a significant margin, and can generate higher quality comments in practical tests. Thank you.
Hi everyone, this is David again. The author of the second paper is already here, but there is some technical issue, and the author is trying to make his way to the backstage area. So while we are waiting for the author, if you do have a question, please post it on the page chat. Yes, there is already a question from Sridhar. Are there some specific properties of smart contracts that you are leveraging for the summarization? Yes, a very good question. So there have been methods that are proposed for Java. It has been shown to work for Python. Are there specific properties of smart contracts that need to be addressed so that the solution can work better? And in the video that we have just seen just now, we see that the proposed approach works better than the number of existing approaches that was originally applied and tested on Java programs. Yes, if the authors are here, please join me in the backstage area. If you can't find your way to the backstage area, please reply on the messages in the chat, right? The question from Sridhar. And then if there are more questions, it can be added to the chat. So if you do have more questions, please mention them in the chat. And then maybe the authors can respond in an asynchronous way after the session is over. So just now we saw the first author was here, and we have chatted also with the first author. Actually, there is some technical difficulty preventing the first author to join the backstage area. Right, so yes, I also have some questions with me, but the time is only like 50 seconds left. So I think it's an exciting area now, this code summarization to be applied to various kind of code, right? Mostly Java and Python, and this is the first time it's applied to smart contract, and maybe there are more software that we can look in the future, and we can actually use, as Sridhar mentioned, specific properties of that new kind of software to guide the code summarization process, and that will be a much more powerful solution. I have the same question with Sridhar on wanting to ask the authors, what are the unique features of the smart contract that is being used here? Yes, and one thing that I note is that in the generation of the code comments, they focus on the notice and def comments of the smart contract, but I do not know much how this information has been used. See you soon at the Q&A the next.